So we are actually given this question, integral 0 to 4 x squared times square root of x times third root of x times fourth root of x times fifth root of x up to infinity. Actually, it's multiply nested. Okay, so to solve this question, what we have to do is we have to first understand the way in which this is represented. And after we have understood how this is represented, we can simplify this and then club that simplified quantity with x squared and then integrate. So if you were to consider the first quantity, it is actually starts with root of x. Okay. Now, after that, you have something as third root of x. So if you are considering the first two terms, then the first two terms form is in this fashion. Now, if you were to rewrite this, it's going to be x parenthesis and the power of x is 1 over 2 followed by the third root of x, but the third root of x is actually within the square root of x. Now this is the representation that we have to place here. Now rewriting this is actually x raised to the power 1 over 2 times x raised to the power of 1 divided by 2 times 3. So this is the exact representation that they are conveying to us. Now let us see what we get when we club first, second, third terms. So rewriting it, so we got square root of x followed by third root of x followed by fourth root of x. Now this is going to be x and third root of x and then the fourth root of x. Now the fourth root of x is present within the third root of x, so that's going to be rewritten in the following fashion. So if I were to place it, it's going to be something like this: 1 over 4 raised to the power 1 over 3, and that has to be raised to the power of 1 over 2. So for 1 over 3, it has to be raised to the power of 1 over 2. And for x, it just has to be raised to the power of 1 over 2. So rewriting this, we are going to have an expression of this fashion: x raised to the power 1 over 2 times x raised to the power 1 over 2 times 3 times x raised to the power 1 over 2 times 3 times 4. So this is how the expression has to be placed. Now let us consider the next four terms if we want to express. So it's going to be square root first, followed by the third root, followed by the fourth root, and followed by the fifth root. So this is going to be x raised to the power 1 over 2 times x raised to the power 1 over 2 times 3 times x raised to the power 1 over 2 times 3 times 4 times x raised to the power 1 over 2 times 3 times 4 times 5. Now if you want to generate for infinite terms, so the expression would be something like this: x raised to the power 1 over 2 times x raised to the power 1 over 2 times 3 times x raised to the power 1 over 2 times 3 times 4 times x raised to the power 1 over 2 times 3 times 4 times 5 times x raised to the power 1 over 2 times 3 times 4 times 5 times 6. Now if you want to rewrite this in a better fashion, then what I would do is I would just place 1 as a multiple, okay, just to get a representation for us. Now 1 times 2. Now what is 1 times 2? It's going to be 2. 2 is also rewritten as 2 factorial. Now what is 1 times 2 times 3 times 4? It's going to be 4 times 3, 3 times 2. That's going to be 24. Now what is 24? 24 is nothing but 4 factorial. Now the same thing can be spoken about 1 times 2 times 3. What is that? 6. Now what is 6? 6 is nothing but 3 factorial. Now going a little bit further, 1 times 2 times 3 times 4 times 5, what is that? That's going to be 120. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So 120 is nothing but 5 factorial. So clearly we can rewrite this expression as 1 over 2 factorial times x over 1 over 3 factorial times x 1 over 4 factorial times x 1 over 5 factorial. You have to know that we have studied a formula which is a power m times a power n can be rewritten as a raised to the power m positive n. So all these expressions can be clubbed and rewritten as x over 1 over 2 factorial positive 1 over 3 factorial positive 1 over 4 factorial positive 1 over 5 factorial positive etc. We can do that. Now having done that, if we are to look into the Taylor series expansion for e is nothing but 1 positive 1 over 1 factorial positive 1 over 2 factorial positive 1 over 3 factorial etc. This can be rewritten as 1 positive 1 over 1 factorial is going to be 2 positive 1 over 2 factorial positive 1 over 3 factorial positive etc. On the left we got e. This can be rewritten as e negative 2 is equal to 1 over 2 factorial positive 1 over 3 factorial positive 1 over 4 factorial positive etc. So we now have an expression for 1 over 2 factorial positive 1 over 3 factorial positive 1 over 4 factorial etc. as e negative 2. So I can now rewrite this quantity as x raised to the power e negative 2. So this is what I've got now. Coming back to the question, integral 0 to 4 x squared times square root of x within third root of x and fourth root of x and fifth root of x etc. times dx. We have already simplified this quantity, so I'm going to place that quantity, which is going to be integral 0 to 4 x squared times x raised to the power e negative 2 times dx. Now this is rewritten as, now we have known from algebra a power m times a power n is a raised to the power m positive n. Now because of this fact, this is going to be integral 0 to 4 x raised to the power 2 positive e negative 2 times dx. Of course negative 2 positive 2 can be cancelled, giving me 0 to 4 x raised to the power e times dx. Now this is constant, e is a constant. We know that the value of e lies between 2 and 3, and because e is a constant, also we know that integral x raised to the power n times dx is equal to x raised to the power n positive 1 divided by n positive 1, positive constant. See, we know this formula. Now because we know this formula, this is rewritten as x raised to the power e positive 1 divided by e positive 1. The limits are 0 to 4. Now if I were to place the upper limit, which is 4, that's going to be 4 raised to the power e positive 1 divided by e positive 1 negative the lower limit 0 raised to the power e positive 1 divided by e positive 1. Now clearly this will be gone, giving us 4 raised to the power e positive 1 divided by e positive 1, which is our final answer.